So special segments of a triangle, perpendicular bisector. What's perpendicular going to mean? Right angles. And what's bisector going to mean? Cutting something in half. So you're going to be cutting the other side in half. So a line or segment that passes through the midpoint of the side, the middle, and is perpendicular. I'm going to get you guys used to seeing that symbol. Is perpendicular to that side. An upside down T is perpendicular. So there's three ways that an altitude could look because there are three sides in the triangle. You could do the one that's going straight down like this. My lines. This is an altitude, I'm sorry. It goes straight to the middle at a right angle. So one could look like this. It goes at the middle, but it also makes a right angle. So that is a perpendicular bisector. The other side, it doesn't actually touch any corners. It doesn't, this is the only one that doesn't go to a vertex because you couldn't make it a right angle and still cut it in half unless it's a special kind. Okay, so you could also have a perpendicular bisector that goes like this. On this side, you could have it go right in the middle, but it has to go at a right angle. That's the perpendicular part. Here's the bisector part. But it can happen to any of the sides. You could have this side get cut down the middle, but it has to get cut in the middle at a right angle. All right, that's what perpendicular bisectors are going to look like. What are you going to look for with angle bisector? You guys know bisector cuts in half. What's going to get cut in half there? You're still asleep? Angle, yep. An angle's going to get cut in half, that's right. And there's three angles. So a segment that bisects an angle or cuts an angle exactly in half. C and T. Bisects an angle of the triangle. So it doesn't matter what it does to the other side of the triangle. For angle bisectors, you're just cutting an angle in half. So we could have one that goes like this. That segment is chopping this angle in half. Chop, chop. You just cut it into two equal halves. But that's not the only angle. You could cut this angle in half. You could start at this angle and you could just chop it in half. And there's absolutely nothing special over on this side. It's the angle that's special, the angle that's getting cut in half. The only time that there's something special happening over there is if it's an isosceles or equilateral triangle. And then you have to be able to cut the third angle in half too. I did that one and that one, so I had to chop this angle in half. So that's what an angle bisector would look like. On any of the angles, it's just getting chopped in half, and it doesn't matter where it lands on the other side. An angle bisector only cares about the angle. Okay, we talked about median already. Anyone still writing? All right, so for median, it goes to the middle or the midpoint of the other side. A segment that connects a vertex, a corner of the triangle, to the midpoint of the opposite side of that vertex. So this one's different. It has to go exactly to the middle of the segment. It doesn't care about bisecting the angle. It only cares about going to the midpoint. So here is a midpoint. That side is being cut in half. And median is going to go from that midpoint to the opposite vertex. So this kind of segment, this median, doesn't care what happens with the angle. That could be bisector or it could be unequal. It doesn't matter. What matters is that the side that it touches gets cut in half. It's a midpoint right there. You could have a midpoint on this side. If that's a midpoint, picture in your mind where the median would be. The median would go, focus up here please, the median would go from the midpoint to the opposite vertex there. And I drew three triangles just so you could see that it's the same for all three sides. I haven't done this one yet. Find the median of that one and mark it as the midpoint on that side. You have the midpoint right there. Then you have the median if it connects the midpoint to the opposite side. So the median is not concerned about the angle. The median is concerned about cutting the side in half. Angle bisector is concerned about cutting the angle in half. And the last one, altitude. Altitude doesn't cut anything in half. Altitude just goes straight down. Think of it like a mountain. If, you know how they say the altitude of mountains? They're not measuring how much it takes to climb up the mountain. They're measuring how high the mountain is from the ground. So you go from one corner and you go straight down at a right angle. So from here to here. I'll put the words in, I'm sorry. That's what an altitude looks like though right there. Sometimes referred to as the height, but we're using the word altitude. A segment that connects a vertex of a triangle, that's like the tip of the mountain, to the side opposite that vertex and is perpendicular to that side. Alright, so then you have an altitude going this way. It doesn't go to the middle, it doesn't cut anything in half. What it does is it goes straight to the other side at a right angle. And if it helps you to flip your paper around to see where that right angle is, that's fine. The drawings don't have to be perfect, but the mark has to be there that it's a right angle. Alright, and I haven't done this one yet. The altitude could go this way. There could be times where the altitude is outside of the triangle if it's an obtuse triangle too. So what I'm going to be asking you to do today, sometimes is identifying one of these definitions and sometimes drawing one of these definitions. So we're going to practice that. Let's do the back side really quickly and then we'll get the iPads out.